Good day, students. This time we'll be discussing another topic in mathematics in the modern world. This is your instructor, Mr. Japheth and Nabaira. But before that, please be acquainted first with these two important features of the E-module. The first one is the checkpoint. If you will see this feature across the E-module, it conveys that you have to check your progress. It could be a practice exercise, a drill, or a thought-provoking question that will solicit your answer to better understand the topic discussed. The second feature is the key to correction. This feature in the E-module will give you immediate answers to the questions that are posted in the checkpoint section. No explanations will be provided to generate your own justification of the answers, hence enhancing your creativity and critical thinking abilities. Alright, so you really have to take note of these two important features because these two features might pop up in any part of the E-module to check your progress. This time we'll be discussing E-module 2.2, expressions, sentences, and variables. For the learning objectives, at the end of this lesson, the student should be able to explain the nature of mathematics as a language, distinguish mathematical expressions from sentences, and use variables to hold objects, state a general principle, and represent a sequence of operations. As an overview, imagine the following scenario. You're in math class, and the instructor passes a piece of paper to each student. It is announced that the paper contains study strategies for students of mathematics. Of course, you will be excited to read this. You are to read it and make comments. Upon glancing at the paper, however, you observe that it is written in a foreign language that you do not understand. Although the ideas in the paragraph may be simple, there's no access to the ideas without a knowledge of the language in which the ideas are expressed. This situation has a very strong analogy in mathematics. People frequently have trouble understanding mathematical ideas, not necessarily because the ideas are difficult, but because they are being presented in a foreign language, the language of mathematics. This statement has something to do with our real-life situation. Many people view mathematics as very difficult because they find this subject alien or it's something new to them. Why? First, because they don't understand how the things in the subject are being presented. It's just because the language of mathematics is new to them. That's why in this lesson, we'll be learning the language of mathematics. First, let's discuss the characteristics of the language of mathematics. The language of mathematics makes it easy to express the kinds of thoughts that mathematicians like to express. It has the following characteristics, according to Fisher. First, precise or able to make very fine distinctions. This is very true because in mathematics, 1 plus 1 is always 2 under natural condition. 2 is always greater than 1. See? Everything is precise. And that's the wonder of mathematics. Next, it's concise, able to say things briefly. Because in mathematics, especially in logic, instead of writing a very long statement, you can just represent it using symbols, like the lowercase letters. So if you're going to write a logical statement in symbolic form, it can be as brief as possible instead of writing a very long statement. That's why mathematics can make everything concise. And lastly, it's powerful, able to express complex thoughts with relative ease. This means that although some things are stated in a complex and complicated manner, but with the use of mathematics, you can write a very complicated statement into a simple formula. For example, the law of acceleration. We know that in physics it's stated in a very long statement. But if you're going to write it in a formula, it's just A is equal to F over M. See how simple it is? So take note of these three characteristics of the language of mathematics: precise, concise, and powerful. Now, every language has its own vocabulary. These are the words and its rules for combining these words into complete thoughts, and these are sentences. And since mathematics is a language also, this is not exempted because it has various symbols. And these various symbols in mathematics will represent the words of mathematics. And if you're going to combine these various symbols, you can create a sentence or a complete thought. But before that, let us first discover the difference between noun and sentences in English, because we'll be using this point of view in discovering the difference between expressions and sentences in mathematics. In English, nouns are used to name things. Of course, things that we want to talk about like people, places, and things, whereas sentences are used to state complete thoughts. A typical English sentence has at least one noun and at least one verb. For example, Anna loves mathematics. The words in red in the sentence are nouns, but the word in blue is a verb. So basically, Anna and mathematics are nouns. And Anna loves mathematics is a sentence because it's a complete thought. Now, in mathematics, we also have expressions versus sentences. The mathematical version of a noun will be called an expression. If in English we have nouns, in mathematics we have expressions. Thus, an expression is a name given to a mathematical object of interest. For example, the set containing 3, that is an expression. The number 5, that is an expression because you name it as 5. The coordinate 1, 2, that is also an expression. That is the name of a certain point in math. So these 3 are examples of expression. To continue, the mathematical version of a sentence will also be called a sentence. A mathematical sentence, just as an English sentence, must state a complete thought. See, if we have sentence in English, we also have mathematical sentence. For example, 2 plus 3 is equal to 5. This is a mathematical sentence. And 10 is greater than 7. This is also another mathematical sentence because it's complete. 2 plus 3 is equal to 5. 10 is greater than 7. So it's complete. The idea is complete. That's why it's a mathematical sentence. To explore more about mathematical expressions, since people frequently need to work with numbers, these are the most common type of mathematical expressions. Numbers have lots of different names. Of course, because we have different types of numbers and we have different numbers in mathematics. For example, the expressions 5, 2 plus 3, 10 over 2, 6 minus 2 plus 1, and 1 plus 1 plus 1 plus 1 plus 1 all look different, but are all just different names for the same number, and that is 5. See, in mathematics, you can name 5 with different expressions. 2 plus 3 is also 5, 10 over 2 is also 5, the quantity 6 minus 2 plus 1 is also 5, and adding 5 ones will give you 5. This means the same mathematical object can be expressed differently. It is the same concept of synonyms in English. See, if we have synonyms in English like beautiful is synonymous to lovely, in mathematics, 5 is synonymous to 10 over 2, 2 plus 3, the quantity 6 minus 2 plus 1. This is just another way of naming the number 5 using different expressions. And why do we use this expression as an example? Because numbers are the most common type of mathematical expressions. Did you get it? Alright, let's explore more about mathematical sentences. Just as English sentences have verbs, so do mathematical sentences. In the mathematical sentence 3 plus 4 is equal to 7, the verb is equal. Can you figure out why? If you read a sentence as 3 plus 4 is equal to 7, then it's easy to hear the verb, or it's easy to observe the verb, and that is equal. See? Indeed, the equal sign is one of the most popular and famous mathematical verbs. Now, if you're going to say 1 plus 3 is equal to 4, then you use equal as the verb. Since we have the verb equal and the subject 3 plus 4, which are called expressions also, 7 is another expression, then if you are going to combine it with a verb, then that will become a complete sentence. That's why it's called a mathematical sentence, because it conveys a complete thought. Alright, I think you have now learned how to distinguish mathematical expressions from mathematical sentence. Hence, as a way of checking your progress, identify whether the following are mathematical expressions or sentences. The first one, 4 plus 5. The second one, x minus 1 is equal to 0. The set containing 1, 2, and 3. 2 plus 3 is equal to 3 plus 2. A plus 7 is greater than 9. Try to think carefully and contemplate which among these examples are expressions and which of them are sentences. You can pause this video for 2 to 3 minutes for you to think deeply about the question and play it again to view the correct answer. Is that clear? Alright, I guess you have now your answer. So here is now the key to your correction. The first statement is an expression. Why? It doesn't have a verb and it's not complete. 4 plus 5, it's not complete. The second statement is a sentence. The third statement is an expression because it's a set. The fourth statement is a sentence. And the fifth statement is a sentence because it's complete. Why? A plus 7 is greater than. So you can hear the verb 9. Hence, it is a sentence. Alright? I guess you have now mastered the lesson in identifying expressions and sentences. Let's continue. Variables. So as you can see in the picture, we use the variable x. In the first few sections of this e-module, you've seen letters like x being used to represent numbers. Letters or symbols used in this way are called variables. Variables are another form of mathematical objects. These are used when quantities take different values. That's why from the word variable, it is free to vary. That's why it can take different values. Imagine taking a car journey and think about the speed at which you are traveling. As you travel along, your speed may change. So, speed is a variable. That is a quantity which can change. So do you understand now what variables mean? Alright, so let's deal into the uses of variables. The first one, variables hold objects. How? See the container and the value? Imagine that the container is the variable and it can hold any object. A variable is a holder, with some suppliers specifying what the variable gets to hold. For example, a rectangle can have any positive height. If the letter h is used to represent this height, then h can hold any positive number. Since based on the first statement, a rectangle can have any positive height, if we represent the height with h, then it can hold any positive number or any natural number. Hence, based on the statement, a variable is indeed a holder. Now, to check if you really understand the concept of variable as a holder, answer this question. If the letter B is used to represent the number of books in a home library, then what could be the possible values it can hold? Alright, so you can think about it since it can represent the number of books in a home library. What could be the possible values? You can pause the video for 2 minutes so that you can think deeper about the concept and then play it again to view the correct answer. Alright, I think you have now your answer. So here's now the key to your correction. The answer is, it could be 0, 1, 2, and so on. Because the number of books in a home library is of course a whole number. It cannot represent a fraction or a decimal. So it could be 0, there are no books, 1 book, 2 books, or the maximum possible number of books. Is that clear? Alright, let's proceed to another use of variable. And this is, variables state a general principle. Often, people need to state a property that is true for so many individual cases. But it is impossible or sometimes inconvenient to list them all. For example, the familiar property of addition of real numbers. If you change the order in which two real numbers are added, it doesn't affect the sum. Popularly, this is known as commutative property of addition. All of the following are particular instances or examples of this fact. 2 plus 3 is always equal to 3 plus 2 because the order doesn't affect the sum. 1.2 plus 2 is equal to 2 plus 1.2. 0 plus 1 is always equal to 1 plus 0. And lastly, 1/2 plus 1/4 is equal to 1/4 plus 1/2. These are all examples of this particular property in addition of real numbers. Now, if you are going to write all the possible cases of real numbers possessing this property, it will be tiring and cumbersome. But with the use of variables, you can state it in a concise and precise manner. How? Clearly, it's impossible to list all cases for which this is true. Here's how we can cover all possible cases using the variables x and y to represent the real numbers. That is, for all real numbers x and y, x plus y is equal to y plus x. See, though we haven't written all the elements of real numbers that can satisfy the property, we can represent them through variables x and y. No matter what real numbers are being held by x and y, the sentence x plus y is equal to y plus x is always true. That is, x plus y and y plus x are just different names for the same number. We have discussed earlier that we can name different numbers with different expressions. So instead of writing all the possible instances and examples of that property, you can simplify it using variables. So this is one of the most powerful uses of variables in mathematics. Do you understand? Alright. It's time to check your progress. If you know how to represent a certain property using variables. This is the property. State a general principle of this familiar property of multiplication of real numbers. If you change the order in which two real numbers are multiplied, it doesn't affect the product. All of the following are particular instances of this fact. 2 times 3 is always equal to 3 times 2. Take note, parentheses in mathematics are sometimes used to denote multiplication. 1.2 times 2 is equal to 2 times 1.2. 0 times 1 is equal to 1 times 0. 1/2 times 1/4 is equal to 1/4 times 1/2. Now, this property is popularly known as commutative property of multiplication. Now the question is, state a general principle of this familiar property of multiplication of real numbers. You can pause this video for a while and think of the possible way of writing the property using variables. Then you can play the video again to view the correct answer. Is that clear? Alright, so I guess you have now your answers. So the property is, for all real numbers x and y, xy is equal to yx. In mathematics, xy means the product of x and y. The same thing with yx. Or you can also write this way. For all x element of real number and y element of real number, xy is equal to yx. They just mean the same thing. Do you understand now on how to write or simplify a certain property using variables? So this is very evident in this fact that mathematics is indeed concise and precise. Do you have some questions? Alright, let us proceed with the last topic. Variables represent a sequence of operations. One of the most common uses of variables is to represent a sequence of operations. So these are the 4 common mathematical operations: subtraction, multiplication, addition, and division. Now take this example. Take a number, multiply by 2, then add 1. Try to represent this sequence of operations using the variable x. Here's how it is. If we let the original number be denoted by x, then the first statement, take a number that will be x, multiplying x by 2 will give you 2x. After that, the next operation is adding 1 will give the result 2x plus 1. Hence, the expression 2x plus 1 represents the sequence of operations: take a number, multiply by 2, then add 1. Can you think of a situation on how can you represent the sequence of operations without the use of variables? It's very hard, right? That's why the use of variables in representing operations in mathematics is very important. Did you get it? Alright, what if we have modified the expression by changing the order of the operations? Take a number, add 1, then multiply by 2. Will the expression also change? Let's see. Again, denoting the original number by x. So we have x. Adding 1 to x, because that's the first operation, will give you x plus 1. Then, multiplying by 2 will give you 2, then parentheses x plus 1. Why did I use parentheses? Because this time, I will multiply 2 to the first expression, x plus 1. That's why I have to enclose x plus 1 in a parenthesis, because if I'm going to write 2x plus 1, then it seems that I have just multiplied 2 to x. That's why I have to include a parenthesis to represent that the whole quantity x plus 1 will be multiplied to 2. Did you get it? Let's continue. The parentheses, as I have explained, are required because we want to take the entire quantity x plus 1 and multiply it by 2. That's why the expression 2 times the quantity x plus 1 represents the sequence of operations: take a number, add 1, then multiply by 2. See, variables are really useful in mathematics. Though I have just presented 3 uses of variables, there are still many uses of variables in math. And you will discover that when you continue learning mathematics, and that is a very beautiful subject. Alright, so to check your understanding, please represent each of the following sequences of operations by an expression using variables. Let X denote the number that you're starting with. And here are the expressions. Take a number, multiply by 3, then subtract 4. The other one, take a number, subtract 4, then multiply by 3. It's just a modified statement of the first question. Okay, so you can pause the video again and think for a possible answer. Then you can play the video again for you to view the correct answer. Is that clear? Alright, you can pause the video for a while to think for a possible answer and play it again for you to view the correct answers. Is that clear? Alright. I think you have now your answers, so here is now your key to your correction. The first statement, take a number, multiply by 3, then subtract 4, will be represented by 3x minus 4. What about the next statement? Take a number, subtract 4, then multiply by 3. That is 3 times the quantity x minus 4. See the difference? It's very easy, right? Once you have understand how to represent an operation using variables, this will be a lot easier if you're going to move to the next step of mathematics, and that is algebra. So, before we end this lesson, take note of this. Just as everybody must strive to learn language and writing before he can use them freely for expression of his thoughts, here too, there is only one way to escape the weight of formulas. Because some people think that mathematics is just a bunch of different formulas. Now, it is to acquire knowledge and understanding of the language of mathematics so that one can turn to the true problems. This is very true because when you understand the language of math, it's easier for you to solve problems in math. Once students understand how things are said, they can better understand what is being said, and only then do they have the chance to know why it is said. This ends our lesson in EMODULE 2.2 about expressions, sentences, and variables. Now, if you want to read more about the topic, here are the references in this EMODULE. We also have the following references: the language of mathematics and variables. Of course, these are the photo credits to the icons that I have utilized in this EMODULE. That ends our presentation of EMODULE 2.2. Have a great day, everyone, and God bless.